Hi there, I just created this new website. Do you like it? I've implemented my own cross-site scripting worm like the Sammy worm. Let's see if it works. Uh-oh, who is that at my door? As a reminder, we should only test out worms on local websites, or else we might end up like Sammy Camcar. Who is Sammy, you ask? Sammy is the author of a cross-site scripting worm known as the Sammy worm. It was used to infect MySpace in 2005. The Sammy worm worked by injecting a malicious script into his MySpace profile, which made the user send a friend request to Sammy, as well as inject the malicious code into the user's profile, causing it to spread at an exponential rate. Within 24 hours, over 1 million MySpace profiles had been affected by this worm, and Sammy had a lot of friend requests. It caused MySpace to be shut down for a few hours. The Secret Service was able to trace the worm back to Sammy, and his house was raided. He lost computer/internet privileges for 3 years. Although this worm was relatively harmless, it showed how fast a worm could spread. It could have also been a lot more dangerous, such as taking advantage of bank account transfers. Now that we've discussed how a website can be vulnerable, I would like to introduce myself and my project. My name is Jerry Morris, and today I will be talking about the dummy website I've built to show website vulnerabilities. Before we demo my website, I will give some background information on the vulnerabilities we will see in my website, as well as how they can be defended against. We will start by looking at SQL injections, then move to CSRF vulnerabilities, and then cross-site scripting. We will then look at these vulnerabilities in a demo of my site. Next, I will have a question I would like to ask the audience, and then I will conclude my discussion. To begin, we will discuss SQL injection vulnerabilities. SQL injection is a technique to inject or modify SQL statements that run on the back end of the website. If there's an input field on a website, it could be used to execute SQL statements. This can be quite dangerous, as an attacker could inject a statement to completely compromise a database, such as deleting the whole database. To provide an example, we will look at some code that is run on my server. I'm currently using a bad query that is an F string where the variables are placed directly in the SQL statement as is. This is bad because a user can take advantage of how SQL queries work, such as how two dashes represent a comment in SQL. Thus, if the server makes a database query by checking the username and password, an attacker could input something like admin with a quote in two dashes, and it would turn the query into looking for just the user in the database without checking the password. The attacker would then have access to the admin account. Thus, to prevent this sort of vulnerability, it is important to use parameterized queries where the variables are separated from the string literal of the database search, causing them to be treated as separate values from the SQL code. A question mark can make a big difference. Next, we will discuss CSRF vulnerabilities. CSRF stands for Cross-Site Request Forgery. This is a method that allows an attacker to perform actions on a website on behalf of the user without their knowledge or consent. This attack relies on the backend code not verifying where the request is coming from and trusting the user's browser. Thus, another website could induce code to be run on the main website. The backend code does not check to ensure that the request is legitimate and coming from a reliable site. For example, I've created an additional website that hosts malicious code to run on the main website. I've set the form to run automatically when the window loads. Using the iframe to keep it hidden, I'm able to send a request and execute this code without user permission. Since the user is logged in on my website, the thread is created under their account. Without the iframe, the code execution is blocked by the Google Chrome browser, and thus the user is made aware of what is occurring. This shows that browsers do have some protections in place, but there are still workarounds. Thus, a website should ensure that requests are coming from legitimate websites. To prevent CSRF attacks, it is important to verify that the request is coming from a trusted site. Since only my website should be sending requests to create a new thread, I can use CSRF tokens to verify that my site in this specific session is sending these requests. Thus, in app.py, I can create the CSRF tokens, and then in the new threads method, I am able to verify that the request is sending the same token that the session has. Now we can talk about my favorite vulnerability type, cross-site scripting. Cross-site scripting is a vulnerability where users can inject malicious code into a website, which then executes on the website. There are different types of cross-site scripting attacks, as the script can be injected via HTTP requests, the website's database, or in client-side code. This type of vulnerability can be quite dangerous, as it can steal user cookies, hijack sessions, and easily steal user information or perform actions on their behalf, such as transferring money from their account to a specified account. For my example, I wanted to create a cross-site scripting worm similar to the SAMI worm. To do this, I take advantage of the bio field on the website and send a request to follow Bobbert, a user on my site. I would like to note that there are already protections in place to prevent fields from executing code by sanitizing input. So, for the purposes of this experiment, I have intentionally allowed code execution by marking the input as safe in the process of bio creation. Thus, to prevent this sort of attack, it is important to consider possible inputs and ensure that sanitation is done to rid of any possible execution types, such as the script tag. As mentioned previously, if we don't mark the input as safe, Flask does HTML escaping automatically to prevent inspections. Thus, if the framework does not do it for you, it is important to implement it yourself. I think it's time for a demo. To begin the demo, I will show you the login process. I have an account with the username admin. I will first show how it looks logging in normally. As we can see, I was able to log in with no issues. Let's log out and try again. I will first try to input an incorrect password. We can see that the site responded with invalid credentials. Now that we know it won't accept anything except for the correct password, let's do an SQL injection on this site. By typing in admin, quote, space, dash dash, we are able to tell it to look up if admin exists, and we are bypassing the lookup for the password. Thus, we are able to log into the site without inserting the correct password. Next, we will look at a CSRF vulnerability. I have set up a malicious website that, when visited and logged into HookieTalks, it will do something in secret. This can be quite dangerous, as it allows the attacker to act as the user and say anything they want. So, we can see that Samuel has said there are cool photos in his bio. Let's check it out. When we go to his bio, we see a link to another website. If we check this out, we see a website that has photos of dogs and does not look suspicious. But if we go back to HookieTalks, we will see that the user has unknowingly posted a new thread, which we can take a look at. Uh-oh, let's delete this before anyone sees it. It would be worse for normal users, as only the admin account can delete threads. Alright, on to the fun part. I can now show you a cross-site scripting vulnerability on my website, which I will call the Bobbert worm. Quite creative, I know. All you have to do is add this worm to your bio, and now, whenever someone visits your profile, they will be infected with the worm. What this worm does is cause the user to follow Bobbert. If we go to Bobbert's page, we can see he has a lot of followers from my testing. Let's prove that this worm gets passed onto other users' bios. We will create account test user 1 and put the worm in his bio. We will then create test user 2 and we will visit user 1's profile. If we go back to user 2's profile, we can see that they are following Bobbert and their bio now has the worm. So let's create a third user and confirm that user 2 is infected as well. Now, if we go to user 3's profile, we see that they are following Bobbert and the worm has infected them as well. Ta-da! The worm is being passed onto other accounts. Bobbert will have millions of followers in no time. Let's hope he doesn't get a visit from the United States Secret Service. So now that I have shown you examples of each of these vulnerabilities on my test website, I would like to ask you, what have we learned in terms of web security? How can we keep these vulnerabilities in mind to create a more secure website? What comes to mind for me is thinking about user input. It is safe to say that user input should not be trusted. This requires sanitation to keep the site secure. It's also important for security to become built in for known vulnerabilities, such as Flask doing some forms of input sanitation. So today, we have talked about 3 different website vulnerabilities, how they can be implemented, and how to defend against them. A demo was provided that showed an example of each vulnerability we discussed. And to conclude, I would like to end with a quote that I think about often. The quote is from Dan Kaminsky, and it goes like this: "The internet was never designed to be secure. The internet was designed to move pictures of cats." And with that, we need to think about security. Thank you all for your time. If you have any questions, feel free to reach out to me at jem29554@vt.edu. Thank you. And here are my references.